This is question number 7 from the 4.1 and 4.2 MyLab Math Homework Part 1, where we just started exploring graphs of functions and connecting those graphs to the derivatives of the functions. So in this question, we're given a quadratic function. I know it's quadratic because the degree is 2. So I know that this is a U-shaped graph. It's a parabola, and I know that it's opening up because that leading coefficient is a positive 2. And the first part of the question is asking me to find where the function is increasing. So another way to word that is to ask, when are the outputs, if the function is increasing, when are the outputs getting bigger and bigger and bigger? Or where are the heights of the graphs going up? So remember, f of x is notation that represents the output of the graph or the height of the graph. When you plug x and input x into the function and you follow the calculation, f of x is the output or the height of the graph. And since I know this is a parabola, a U-shaped graph opening up, I can see that the heights, even if I didn't know where the axis was, I could graph this on Desmos if I wanted to, but Desmos is not allowed on test 3. So even if I didn't know the heights of the graphs, I could see that the heights of the graphs are decreasing, right? So they're dropping as I move along my x-axis until I get to this minimum point. This is a local minimum. That local minimum is the lowest output or the lowest height of the graph as I'm moving from left to right across this parabola, and then my heights start to increase again. Okay, so my function is actually going to be increasing to the right of that local minimum because the outputs of the graph or the heights of the graph are getting higher. So there's a couple ways to figure out where that local minimum would happen. If you remember from your algebra class how to find the vertex, you can totally do some algebra here. Again, you can't use Desmos or a graphing calculator because that won't be allowed on test 3. But another way we can figure out where this local minimum is happening is with calculus. We know that when the graph was decreasing, when the heights of the graphs were going, of the outputs were going down, that's when my tangent lines had negative slopes. And then here at the local minimum, the slope or the tangent line went horizontal, so the slope of the graph at whatever that point is, at that minimum x value, went to 0. And then the tangent line started pointing up, so those slopes started being positive again. So the graph has increasing outputs when the derivative is positive, when those tangent lines are pointing up. Another way to say that is when the derivative is greater than 0. So I can figure out this point where that shift happens from negative tangent lines to positive tangent lines by setting my derivative equal to 0. So we were given this function value, function rule here. It was a quadratic rule, 2x squared minus 12x plus 2. And so I can take the derivative just with the power rule. Since x is the input variable, that just means I don't need the chain rule because x prime would just be 1. So when I take this derivative, I'm going to get 4x minus 12. And I'll just set that equal to 0. And then it's just some simple algebra from there. So if I set this equal to 0, I'll just add 12 to both sides. And then we'll divide by 4. And I can see that x is 3. Okay, so if I put 3 into my derivative, I would get an output of 0. That means up here on this graph that I've sketched here, when x equals 3, that's the threshold or the boundary between where the graph was decreasing. So here's my graph was decreasing. When I hit x equals 3, that's the point where the tangent line went horizontal. And then after that, my tangent lines were pointing up, so my outputs are increasing. So that's how I got this interval here. So where was the graph increasing? I started at x equals 3, but I put a parentheses there because when x is actually equal to 3, the graph is neither increasing or decreasing there at that local min. So I didn't want to include it. If I'd put a bracket, it would have included it. So I didn't want to do that. So I put a parenthesis. But then it's going to be increasing forever because we know it's a U-shaped graph. There's no turns after that point. You know, it has to keep that U shape since it's quadratic. So the graph is going to be increasing from +3 all the way to infinity, positive infinity, all those x values. The next part of the question is asking where it's decreasing. That's where those tangent lines would be negative. And since it's a parabola, I know that's just the other half of the graph. So that's how I got from negative infinity up until I hit 3, not included. And then this last question is just asking us to find any local extrema. That's a local min or a local max. And we've done that when x equals 3. But x equals 3 is where the local min is happening. It's not the actual minimum of the function. The minimum of the function is that lowest output or that lowest height on the graph. So I know it's happening when x equals 3, but to actually find the local min, I have to plug 3 back into that original function, because remember, the original function gives you all the points on the graph. So when I do that, I get an output of -16. So when x equals +3, the output is -16. And that's going to be the local minimum value of that function. So let's see, which one would we pick here? It's not a local max, so B is out. No, yeah, it definitely has an extrema. So it has a local minimum, so f of 3, and it's going to be a -16 there. And there's no local max because of the shape of the graph. It's U-shaped. It's going to point up in both directions forever. So there's a local min, not a local max. So again, most of this is algebra review. I just used some calculus in this problem to find that x equals 3. Again, you could have used your vertex formula to find the vertex of a parabola if you remembered that. Let's actually, -16 seems weird. I'm going to go to Desmos real quick and we can graph that. Okay, so I graphed it here on Desmos and I zoomed out. So that looks right. I'm just going to go ahead and double check here. One little thing. Let's just plug that in. So f of, what did we say it was? 3? F of 3. Yeah, -16. Okay, there it is. I'm going to go ahead and graph that just to be certain. Yep, there it is down there. That's our local min. Okay, cool. Now remember, you can't use Desmos on test 3, but you can definitely use Desmos when you're doing your homework and when you're learning the concepts to check your answer and to connect dots and, just help understand the concepts. Just wean yourself off of the Desmos because it's not allowed on test 3, and neither are graphing calculators. So keep that in mind. And as always, email me if you have any questions.